Shortest unsorted continuous subarray. So you are given a subarray. Okay, let me go through this problem, try to explain you. So you are given this subarray, for example, 2, 6, 4, 8, 10, 9, 15. So they are asking you, what is the shortest subarray which you can sort to make it actually sorted? So this is the thing. Okay, the question is clear, because if I sort 6, 4, 8, 10, 9, then this will get sorted, then everything towards my left is already sorted, towards my right is already sorted. This, if this middle thing gets sorted, then the overall array will be sorted. So that's the problem. You have to find what is the length of this unsorted continuous array. So I can try to explain on the drawing board also, but yeah, let me go through it. The problem will be something like some value. Suppose if it was all sorted automatically, then you will have increasing kind of sequence. Not a straight line, but I just drew it because it's easier to draw a straight line. But everything is increasing. In this particular case, you can have something like this. Hey, like it increased up to some time and then it decreased and then it again went up, right? Things like that can happen. Or it can have more like, such thing like, okay, increase, decrease, increase, decrease, something like this. So in this particular case, if you sort some values in this area, like wherever it is, then probably this will get sorted. Something around this area, if they get sorted, it will be overall sorted. So your example was actually 2, 6, 4, 8, 10, 9, 15. So what information you can make if everything was sorted, then you will never see this thing like, this, nobody will be kicked out in the process, the kicking out process which we just discussed. When you are building something, then and nobody is getting kicked out, then you know that everything is in order. But what will happen in this particular case, when after 2 you will add 6, things are okay. But after 6, when you will add 4, things are not okay. So you have to kick out 6 here, right? So if you have to kick out 6, then that means you have to actually consider looking here, because we know that actually, hey, there is some problem here. So maybe you will say, okay, look at this guy. Now, as Gaurav was saying, like, from this side, if there is something sorted, if we start looking from this side, from the right side, so from this side, so if things were all the things were sorted, then the decreasing stack, if we build decreasing stack from the right side, it will also not see any like, kick out process, no exception to the rule. So in that particular case, things will be okay. But in this particular example, if you look at it, 15 to 9 is fine. But when you come from 9 to 10, you know that it is not it is not decreasingly sorted, because we found a value which is not adhering to this decreasing rule. So now this is the guy which we have to consider. So the idea is, if we can find these two extreme ends, and we sort these two, then we know that overall it is sorted.
Hey,
Uh,
I have like one question here.
yeah,
What if the previous numbers are, let's say, 20, 19, and 21,
20, 19,
and
20.
21, 21, and then the same array, 8, 10, 9, 15.
Oh, you are saying the same array. I should append these values, you are saying?
No, no, no. Like instead of 2, 6, and 4,
Yeah,
replace these.
okay. So 20, 19, so 264, okay, make it 20,
Yeah, 19
19,
and
21.
21, and then like 8, 10, 9,
8, 10, 9,
15.
15, right? So when you
Because
are,
in this case also, yeah,
yeah. So in this case also, when you will go from left to right in the increasing sequence, so 20 will be the first guy who is not adhering, right? Because I'm first going through left to right, building an increasing stack to figure out this left side of the extreme.
or instead of like 19, like maybe I just like messed it up. We take like 20, 20, 22, and then 21,
20, 22,
and
and
then
21.
21. Then yeah, so
Yeah,
just trying to take the same example, because here also we will figure out that 22 is the culprit.
yeah, yeah. So here again, 20, 21, 21. When 21 comes back, so we definitely know this guy is not at the right pace. Just looking at this, right?
Correct.
So this guy is definitely the person who needs to be like, considered. And then we will continue going like right side also. And you may find maybe something is totally like uh, like everything is decreasing afterwards, right?
Yes, for the only reason I took this example was because we figured out like 6 and 9.
Hmm.
In the current example as the tripping point where we know like from 6 to 9 we have to, if we can sort, then the whole array is sorted, depending
Yeah,
upon, yeah. But in this case, like the higher number is 20.
yeah,
Like onto the very left we have 20, and onto the very right we have 15. Okay, so if we go from left to right we will figure out 22, and if
yeah.
we go from right to left we will figure out 9. Okay, so definitely 22 and 9 are not the correct answers.
Right. So you will also continue actually, so you will not stop there itself. You will continue popping out values. So you remember that when you will pop out in future, so let me write here 20, 22, 21, and we have suppose same thing like 648. What do you want to put here?
8, 10, 9, 15.
8, 10,
9,
9,
15.
15.
Yeah,
So, okay. So this is the first time we figured out, hey, there is some problem with 22. We will consider this guy. But I'm saying we'll consider, not like this is the like, guy. So we'll maintain 22, 21 was fine. Then when 8 will come, what will happen? We are maintaining this guy, increasing, right? So 8 will kick out even 20.
makes sense.
So what will happen? Your consideration is already here when you will go through the entire process.
Okay, so we will move back.
Yeah, we'll move back. So we will not just find one and we are breaking. No, we are not going to do that. Got it?
Yeah, make more sense now.
So same thing, same idea, and it's good to like put more examples to like figure this thing out, because actually sometimes you will put example, you will figure out that actually you are not understanding things that well. I tried to optimize some things and I was getting error myself while I was going through some of these problems. But yeah, this is how it works. Go through it, you will figure out where to stop, how to optimize. So the concept is clear, guys, right? We'll find both the extreme, and once we find both the extreme, we have to just return the difference between this left extreme and right extreme, because that's what they are asking, like how many days after that you will have the same. Actually, no, it's a continuous subarray, so you have to sort these values.
I have a question. Last time we with one iteration we can figure out both answer for in both array, right? Why can't we do the same? Why can't we do the same in this problem?
Oh, that what do you want to calculate the first? So in the previous, like, we Gaurav just discussed something, right? That when you are, what you are interested in, like, that increasing stack, you are building increasing stack that will give you first a smaller value, right? First a smaller value, whether it adheres to the rule or it breaks the rule, you always get the smaller value. But you also have to get some higher value, like what is the first like, bigger number towards left or right. You are interested in that too, right?
Right.
Or just do it from, like, decreasing way from the right, which means the same thing. So anyway, you have to go through that process. So it's a good thinking, but that's why in the beginning itself I told you, I recommend after this session, go to the same problem with the current understanding and run some examples and try to apply it. And maybe I am not giving you the best solution. That's possible because I haven't devoted too much time to testing all those things. What I'm trying to give you is a framework where you can apply all these things and it will work. Maybe you can optimize it, but as I talked in the beginning, that is not like, currently we are not going to go into that. Is that fair?
Yes, I guess like we may optimize it, but then like it's like a very hard to visualize right away because you have to maintain like some additional information. So the simple solution like which we can combine to come up with the solution with the bigger solution should be straightforward to understand.
Yeah, I mean, that's what we decided in the beginning itself, that this is what we will do today. So if you have a better solution or we want to discuss, we can always discuss after the session, and then feel free to suggest ideas.
Yeah, I'm looking at it. I don't think it's gonna work because for first iteration we have to maintain the stack in increasing order, and in this case, the second iteration we have to maintain the stack in decreasing order. So it's not applicable to.
Yeah, that's what I thought, but yeah, I never tried to optimize it. So with that, any further questions? Now like at least one way to solve this, right? Increasing from the beginning uh, and then decreasing from the end, and we figure out those two extremes. And if these two extremes, if we sort that, we get the answer. So with that, actually, let me share my code very quickly. It's the exact same logic which we just talked about, and I have added some comments, so that will help. Find first value from left, which is not correct, and monotonically increasing stack, we are building that. We found the leftmost value. Similarly, when going from right to left, we did the same thing and we figured out the right value. And after that, we just return the difference between that. So that's this problem.